All right, well, good afternoon, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Warm up 85's on the screen, and the z-score is for number 4, not 40. My bad. Nice. So let's get started, please. Also, today we're going to wrap up our counting rules. So hopefully you got your horses, right? So you can hold your horses. Nice. All right. So let's get cracking, please. All right. Here we go. Number 1. Let's get the bell curve going. Mia, mean. 23, Michael Jordan. 0.3. 23.3. Hands if you got that. All right. So we need a variance. Pass someone. Mia. Variance. Leslie. You're still working on it? Patricia, help her out. Variance. $3.2. The variance. 342.27. Hands if you got something like that. Okay. Standard deviation. Pass someone. Amy. 18.5. Looks about right. So 23.3 plus 18.5. That's 41.8. Is that correct? All right. And on the flip side, we are at 4.8. Yeah. Okay. So that's our normal range. We need a z-score for 4. Pass someone, Amy, z-score. $1.15. Hands if you got that. Looks about right. So -1, we go past their normal range. 0.15 is about over here, which means they're outside the normal range. Okay. Let's go to the factorials. Pass someone. Number 2. Whoa. Minus. $24. Therefore, this is 96. Hands if you got that. Looks about right. All right. Copy the agenda. Warm-up number 85, combination rules. Today we're finishing off our counting rules with the last rule, which is the combination rule. And tonight you're going to have 6 problems of review for all different ones that we've covered so far. Okay. And so yeah, we're finishing off with this section because the next section that we're starting, we're going into gaming probability. Let's go. So for those of you that are lotto enthusiasts or you like playing poker or 21 and all that, there you go. We're going to get some numbers into that, and hopefully that'll help you out. Thank you, Miss Q. You're welcome. All right. Once again, warm-up number 85, combination rules, 6 counting rules. I'll show you those 6 at the end. But get a Cornell note ready, please. I can identify and compute the basic probability. Can identify and compute basic probability. So we're still, like I said, we're still in the middle of the counting rules. We're finishing off the last rule today. And just to double check to make sure where we're at so far, we got our basic probability stuff that we've been covering so far. And then rules. What kind of rules have we covered? We covered the fundamental counting rule. By now you should know that one, right? Saying ever what it is, just in one word. Very good. Factorial. Good. All right. Next one. Permutation rule. Tell you never the rule without looking at your notes. Very good. And today, the last rule is the combination rule. So with that said, copy the rule, please. There it is. You don't have to copy all the verbatim. Now, just FYI, the previous one on the permutation, even though I did record the video, I don't know if I mentioned to you guys that I've been having computer issues, and this is a new one according to, Leslie. I just got it, I think, this year, or no, last year. Should be fairly new, but it's been glitching. And then when I went to retrieve my video that I recorded, it said error, and I couldn't upload on YouTube. So there you go. So just a quick recap on permutation. Permutation, on the rule that we covered last time, permutation meaning that it has a specific order. Or in other words, order does matter. So for this one, look up to the screen. I want you to write somewhere, order doesn't matter. So when they're giving you a situation, whatever that situation is, then we use this rule, and that's when the order does not matter. That's why it's just called a combination rule, simple combination rule. All right, do we know all the components? All right, so tell your neighbor the components, please, and then I'll have somebody help me out. What does that one mean, and what does that one mean? All right, N, JC, what does that mean? Yeah, the total number of objects, okay? How about the R, Pedro? Yeah, the selected objects, This is total objects, whatever it is that they're talking about, objects. So whenever they're talking about whatever objects, look for the total and then look how many they're selecting out of the total. So those are the two that we're going to be working with. All right, let's get started. Number one, here we go. It says, a newspaper editor has received 8 books to review. He decides that he can use 3 reviews in his newspaper. How many different ways can these 3 reviews be selected? Don't copy the problem, write your formula first. All right? Read me the formula, please, Zach. What's that? Oh, N. N factorial. Times R factorial. Okay. All right. Before we go forward, tell your neighbor the difference between this one, that the order does not matter, to the permutation rule, that the order does matter. What's the only difference from one to the other? The only difference. All right. Let's see, JC, give us the permutation rule. Bless you.
The permutation rule
Yeah.
is n factorial, or nc
NP.
r equals n factorial over n minus r factorial.
All right. So look at it. Does everybody see see the difference between that one and that one? Yes? All right. So just wanted to point that out. So with that said, how many total, everyone? 8. How many objects are they selecting? 3. All right, so let's do that. We got 8, 3, 8, 8 minus 3 times 3 factorial. All right. So, see what you get for that. I'll give you some time. Go. All right. So, what you get for this one, Jet? Total. How much? 56. Hands if you got 56. No? Okay. You did? All right, let's double check. So we got 8. That's 8 factorial. And then we got 8 minus 3, that's 5 factorial. And then times 3 factorial. So what does that mean? That we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 factorial. And then at the end times 3 factorial. 3, 2, 1. So that leaves us with that divided by that. So 7 times 8, oh wait, we can reduce a little bit more, right? What is 3 times 2 times 1? 6, cancel 6, and that leaves us with 56. Or, if you want to multiply it out, 8 times 7, 56 times 6, divided by 3 times 2 times 1, which is 6, and you get 56. All right? From 1 to 5, how comfortable are you with this? 4s, 5s, 4s, 5s, okay. Let's crank it up a little bit, yeah? Oh, yeah. Copy this one. Copy it on your paper. Example 2. In a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? Copy that first, and we'll do this one together. Okay, here we go. Let's take this by parts. Start with the woman. 7 women, and they're picking how many? 3. Okay. So underline that. If you have greens like that, we can use green for them. So then we write our rule. N combination R equals, you're right over there, Vince? All right, just checking. N factorial over, parentheses, N minus R factorial times R factorial. Okay? And then I'm going to switch to blue. And then again, n, combination r, n factorial, n minus r factorial times r factorial. And at the end, we need to do this. Look up. Is everybody seeing what we're doing? All right. All right, so go ahead and find me this, find me that, and then find me that at the end. I'll give you some time. Talk it over with your neighbors so they can see what you're doing, please. Go. All right, let's see. JC, what'd you get for the woman? Oh, close. We got something different. Alejandro, what'd you get? 35. That is correct. 35. Check your math, please. 35 times. Catch it or? Yes, no, maybe so? All right, let me show it right here. We got 7, 3, 7, 7, 3, 3. I don't know why, but I wrote 8 on top. Oh yeah, let's write 7. All right. 7 factorial, so then we have 7, 6, 5, 4, 3, 2, 1 over 7 minus 3 is 4. 4, 3, 2, 1 times 3, which is 3, 2, 1. So then this is 210 divided by 6. Is that correct? And that gives us 35. All right. Hands if everybody's following. Yes. Okay. For the men, what'd you get for the men? Male. 10. Hands if you got 10. That is correct. Double check your work if you didn't get 10. Once again, get organized. This should be 5 factorial over 5 minus 2 factorial times 2 factorial. Yes? Which is 5, 4, 3, 2, 1 over 3, 2, 1 times 2 and 1. So this is 20 over 2, which is 10. So the total, 350. Different possibilities. From 1 to 5, I'll come to you with that. All right. Let's do another one. Oh, yes. Copy. No, don't copy this one. Write your formulas. It says, how many different ways can 4 baseball players and 3 basketball players be selected from 12 baseball players and 9 basketball players? Go. All right, let's see. Amy, help me set up the one for the baseball players. What do I write? 12, okay. All right, so that is factorial factorial times factorial. Okay. So this becomes, let's see, 12 factorial over 8 factorial times 4 factorial. So that means if we get rid of 8 and on, we're left with 12 times 11 times 10 times 9. So far so good, yes? And then 4 times 3 times 2 times 1. Is everybody following up to right there? If you don't see it, once again, you need to write out 12 times 11 times 10 times 9 times 8 times 10 all the way to 1, and then the 8 all the way to 1, and all 8, 7, 6, 5, 4, 3, 2, 1, they become giant ones. And then again, you write 4, 3, 2, 1. So this is, let's see, 99 times 12. What is 99 times 12? 1,188 divided by 24, and that gives us what? So we got 495 times guys, I'm going a little bit faster because we already did these factorial practice on the warm-ups, and I'm assuming you guys can see it. If you don't see it, then write it out, such as 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1 over 8. That means 8 times 7 times 6 times 5, 4, 3, 2, 1 times the 4, this one, which is 4 times 3 times 2 times 1. Giant ones. What is 1 over 1? 1. 2 over 2? 1. 3 over 3? 1. 1. 1. 1. 1. 1. What is 1 times 1 times 1 times 1 times 1 times 1 times 1? Still 1. And that leaves us with what? This, which is here, and this, which is there. Then you just multiply those to get that, and you divide it. All right. So, basketball players, what you get for your total? Samuel. 84. Hands if you got 84. All right. So in total, different ways, 495 times 84. Eric, what'd you get? Hands if you got that. All right. Looks about right. Okay, from 1 to 5, I'll come to borrow you with this. All right. And that concludes our counting rules, guys. So, this is what I'm going to do. I'm going to go to the next slide. Don't copy it. Just look up. And tell your neighbor the rule for this one, the rule for this one, and the rule for that one. See if they remember all three of them. Start with Zach. Go. First one. Zach? First one? And if you guys talked it over with your neighbors. It's what? N times N minus 1 times N minus 2, dot, 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 and so on and so forth. Or in other words, kind of like just saying what? Factorial. Whatever the number, factorial, yes? All right, permutation rule. N of P, R, N factorial, N minus R factorial. Combination rule. N, C, R, N factorial, N minus R factorial times R factorial. All right, so what's the difference between permutation rule and combination? When do you use one and the other? Let's see, talk it over your neighbors, see if they get it by now. All right. Let's see, Dom, what do you say about permutation? Yes. Oh my goodness. What's the difference between permutation rule and combination rule? Okay. I'm saying, when do you use one compared to the other? Help them out, Matthew. Jet.
Use the permutation rule when there's a specified order, and use the combination rule when there's no order.
That is correct. Whenever there's an order that matters or there's a certain sequence to follow, you use the permutation. When there isn't an order to follow that you can just select, then you use the combination. All right. Let's put that to the test. Here we go. Don't copy that. Look up to the screen. It says, how many different ways can 4 tickets be selected from 50 tickets if each ticket wins a different prize? Think about it. Think about, let's put it in the context of raffles that you've seen before. Have you guys seen raffles? They take out a ticket. Somebody gets a prize. They took another ticket, another prize, and so on and so forth. So, neighbor, which formula would you use for that one? Or what question shall you ask? Tell your neighbor, what question shall you ask? Yeah, does the order matter? All right. So with that said, Andrew, permutation or combination? Close. Order does matter. Why? Because each person gets a different price. If they all got the same price, does the order matter? No. So I heard Mel say, does the order matter? Yes, the order does matter. All right, let's go to the next one. A foreign language club is showing a 4-movie marathon of subtitled movies. How many ways can they choose from the 11 available? All right, tell your neighbor which rule would you use, permutation or combination? All right. Let's see, Presidenta, permutation or combination? That is correct. Order does not matter because they can just select the 4 different movies. All right, let's go to the next one. How many ways can an advisor choose 4 students from a class of 12 if they are all assigned the same task? I'll stop right there for that question. Tell your neighbor which rule to use. All right. Pedro, go. I'm sorry? For the first question. Oh my goodness. Vince. First one would be permutation because it doesn't show a specific order. How many ways can students be chosen if they are given each a different task? Tell your neighbor what rules to use. Oh, my bad. I did it backwards. The first one is combination, because the order doesn't matter. On this one, it does. Different tasks. My bad. Last one. An investigative agency has 7 cases and 5 agents. How many different ways can the cases be assigned if only one case is assigned to each agent? Tell your neighbor which rule to use on this one. Imagine you're the one that's assigning the cases. You have a backpack with 7 cases, and you're going to go and distribute that one for each of the 5 agents. Which rule? Aaron. What is it? Permutation. That is correct, because it doesn't matter which case they get. You're just going to give each one one. So with that said, let me go back to that one. Example Q. Write your formula. Find me the, we still have time. Find me how many different ways, different prices. Bless you. How many different ways can 4 tickets be selected from 50 tickets, and if each ticket wins a different prize? Copy and go. Also, get your phone out. I'm going to post the home place. You can take a picture. For each of those, you don't have to copy the problem. Just show me your formula and find the computation part. I'll stop the video right there. Enjoy. Bye.